Hello, everyone. Good morning, good afternoon, or good evening. The authors, distinguished session chair, and invited guests. Welcome to Technical Session 11E. I'm Sanskriti Khamkar, and I'll be moderating this session today. On behalf of the Global Knowledge Research Foundation and GR Scholarship, it's my great pleasure to welcome you to the 11th International Conference on Information and Communications Technology for Sustainable Development. That is ICT4SD 2026 in Goa, India. The 11th edition of this conference is being conducted in a hybrid mode. The physical conference was held on 9th July in Goa, India, while the virtual conference is being conducted via Zoom from 9th to 11th July 2026. I hope you enjoyed today's informative and engaging technical presentations. In this session, we have 10 paper presentations. Each presenter will be allotted 10 minutes for the presentation, followed by 2 minutes for Q&A. At the 9-minute mark, I will give a gentle reminder so that we can maintain schedule. I also request all participants to stay connected with us until the closing remarks. If you have any questions or require any assistance during the session, please feel free to message me through the chat. Now, before we begin, it's my privilege to introduce the session chair for this session. Dr. Mahesh Sanghavi is a professor and joint director at St. James College of Engineering, Chandigarh, Maharashtra, India, with over 21 years of academic experience. Specializing in image processing, DBMS, big data, and IoT, he's published widely across Scopus, IEEE, and Springer channels. His key contributions include serving as an official syllabus setting committee member for Savitribai Phule Pune University and receiving the Best HOD of the Year award from the Computer Society of India. The honor to have you here with us, sir. So, would you please like to share any remarks? So, we'll be starting with the presentations now. Our first presenter is Devajyoti Day, who will be presenting the paper titled A Feature Optimized Deep Ensemble Architecture for Robust and Explainable Defect Detection.
Am I audible?
Yes, you're audible.
Let me start sharing my screen. I am Devajyoti De, and I would like to start my presentation.
Your screen is being shared.
Is my screen being shared currently?
Yes, it's visible.
Just wait a few minutes.
Devashiti, your screen is visible. Please start.
Okay. Hello, everyone. My name is Devajyoti De, and today I'll be presenting our paper titled A Feature Optimized Deep Ensemble Architecture for Robust and Explainable Defect Detection. This research was conducted alongside my co-authors, Mr. Rahul Modak, Dr. Kaushik Majumdar, Mr. Mihir Singh, Dr. Saikat Bhaskar, Mr. Shantanu Chatterjee. So let's dive in. We'll begin by addressing the core issue, the deepfake threat. Generative technologies have evolved rapidly, and it has allowed for the creation of a highly realistic, artificially altered media of real people doing things they never actually did. This poses severe societal dangers, including massive financial frauds like CEO impersonation scams, like millions of dollars lost and other political sabotage, propaganda, extortion, cyberbullying, etc. Severe personnel harassment. So this is a massive threat, and we need uh, powerful mechanisms to uh, counter them. Now the evolution of detection mechanisms. To combat this powerful deepfakes, detection mechanisms have evolved from checking handcrafted features like blinking or head pose to using single stream CNNs and most recently vision transformers and ensembles. However, current state-of-the-art methods have notable limitations. For instance, single model architectures often struggle to generalize across different datasets, while stacking multiple networks creates the curse of dimensionality, introducing the redundant noise and requiring heavy computational resources. Methods like face X-ray are becoming obsolete against white, like subtle blending, and also other approaches sometimes fail on complex manipulations like full head swaps. This is the table of the comparative analysis of recent works we have studied. Now, this leads to our motivation. We aimed to solve the defect detection trilemma, balancing generalization, efficiency, and accuracy. Our goal was to create a feature-optimized deep ensemble. To achieve this, we set specific objectives, integrating four complementary CNN backbones to capture a diverse set of features, implementing a hybrid wrapper-based feature selection method to eliminate noise, and achieving robust performance on unseen in the wild data. Here is the overall overview of our proposed methodology. Our methodology is a multi-step pipeline. Step 1 involves pre-processing video datasets using MTCNN pipeline to extract localized face crops. In step 2, we extract features using four heterogeneous complementary CNNs. Inception ResNet V2 for multi-scale representations, EfficientNet V2 V3 for efficient structural extraction, Exception for texture artifacts, and CSP Darknet 53 for facial geometric features. To enhance these representations, we added a squeeze and excitation block after the last layer of each CNN, then a global average pooling layer for the feature extraction, then dense layers so that the model learns nonlinear relationships on a deeper level, then culminating in a highly detailed when we concatenate all the features coming from the CNNs, we get a 6,144 dimensional feature vector. This huge feature set gets fed into our optimized feature engineering engine, feature selection engine, which reduces the huge feature set to an optimal relevant only subset that our classifier can efficiently handle and give highly accurate results. Now, here is our hybrid feature selection pipeline. Here, our feature selection pipeline is divided in two blocks. One is we start the initial baseline by applying 5 ranking algorithms, get the average ranking, and based on the average ranking, we get an initial subset upon which we run our optimizer algorithm, which is named heuristic pruned taboo optimizer, an algorithm based on taboo search to obtain the near optimal relevant only subset. Now, finally, our novel algorithm. This is the core of our optimization. The heuristic-prone taboo optimizer or HPTO is a combination of taboo search memory mechanisms to avoid local optima and heuristic branch pruning for efficiency. This algorithm evaluates feature fitness by balancing predictive accuracy with a penalty for larger feature sets, what we call the Occam's razor formula. This result is an impressive 80.5% feature reduction, shrinking our vector from 6,144 under 1,200 highly relevant features. This is our fitness function where we have utilized threefold stratified cross-validation for calculating fitness to reduce biases and applied a O1 global caching layer so that we don't recalculate the subsets and improve efficiency. Now, this is our final classifier. We have chosen cat boost because of its ordered boosting strategy that effectively avoids target leakage and prediction shift, making it highly robust against overfitting compared to algorithms like XGBoost. Furthermore, its symmetric trees execute extremely fast during inference, which is critical requirement for real-world real-time deepfake detection. Now, our datasets. To validate our framework, we use three distinct benchmark datasets. We use Face Forensics Plus, which provides balanced data with four manipulation types. SelectDF V2, which offers high difficulty with reduced artifacts, and Wild Deepfake, which contains diverse, compressed, and noisy real-world internet videos. Now our experimental results. Looking at our intra-dataset results, the proposed ensemble vastly outperforms single models, but the most significant takeaway is from our cross dataset evaluations. We found that training our model on the diverse in the wild videos from the wild effect dataset allowed the model to learn universal forensic fingerprints. As a result, it successfully achieved a highly robust detection on unseen datasets. Like we can see 89.04% area under the curve score when tested on face forensics. This is the state-of-the-art comparison. When compared directly to recent state-of-the-art methodologies, our architecture proved superior. Our proposed method achieved a remarkable 99.44% and 99.77% on the benchmark Celebdf V2 and
Excuse me,
Space
Ladies
Function.
Yati. Sorry to interrupt you. This is just a gentle reminder that 1 minute is left for your presentation, so please conclude.
Okay, okay, this is our explainability grad camp heat maps. This is a future scope, space-time attention, references. Thank you. I'm ready to answer any questions.
I believe there are no questions. So we'll be moving forward with the next presentation. Can you please stop your screen share?
Okay. Thank you.
Our next presenter is Vandana Swain, who will be presenting the paper titled A Novel Adaptive Defuzzification Method for Trapezoidal Interval Type 2 Fuzzy Sets and its Application in Multi-Criteria Decision Making.
Good afternoon, everyone.
Good afternoon, Bandana.
Is my screen is visible?
No, it's not. Bandana, please do the presentation.
Is my screen is visible?
Yes, it's visible.
Thanks. Good afternoon, everyone. Myself, Vandana Swai. Here I am presenting my topic, a novel adaptive differentiation method for trapezoidal interval type 2 fuzzy sets and its application in multi-criteria decision making. Here these are the outlines. Introduction. In real-world scenario, the decision-making often involves evaluating multiple alternatives with respect to several conflicting criteria. Such problems are commonly known as multi-criteria decision-making problems, where uncertainty creates a challenging scenario to solve multi-criteria decision-making problems. To solve these difficulties, trapezoidal interval type 2 fuzzy sets have been proposed for multi-criteria decision-making problems in which differentiation process is an important part to solve decision-making problems. The differentiation process is used to get reliable outcomes. Currently used different methods are reliable but face difficulty to get perfect unbiased result in complex scenarios. So this study proposes a new differentiation process which uses trade measure, center approximation and average expectation to handle high level of uncertainty. The proposed technique will provide appropriate and strong ranking stability with reliable outcomes. The outcomes demonstrate how the suggested approach might improve decision quality in uncertainty in practical applications. These are some basic definitions. First one is fuzzy set. Here fuzzy set, let A be a fuzzy set and A is defined by equation 1 where mu x is membership degree of element x and its value lies between 0 and 1. Next definition, type 2 fuzzy set. Let A be a type 2 fuzzy set and it is defined by equation 2 and mu a x u represent the secondary membership function and its value also lies between 0 and 1. Next definition, interval type 2 fuzzy set. Let A be an interval type 2 fuzzy set which is defined by equation 3. The uncertainty in the interval type 2 fuzzy set is bounded by two membership functions, that is upper membership function and lower membership function. And the region between upper membership function and lower membership function is called footprint of uncertainty. Next definition is the trapezoidal interval type 2 fuzzy set. Let be a trapezoidal interval type 2 fuzzy sets where first bracket represents the lower trapezoidal parameter and the second bracket represents upper trapezoidal parameter. And HL, HU denote height of the lower membership function and upper membership function respectively. Here is the framework of our algorithm. First, we will input trapezoidal interval type 2 fuzzy set B. Then we will compute average expectation, centered approximation, spread measure. Then we will compute uncertainty index. Then we will find the weights alpha, beta, gamma. Then we will compute differential value dB. Then we will rank the alternatives based on the differential values. Here is the mathematical formulation of algorithm. In step 1, a trapezoidal type of set is defined as P, which is defined as in equation 4. Then we will compute average expectation, central approximation, square measure as equation 5, 6, 7. Then we will calculate uncertainty index by equation 8. Then we will calculate value of alpha, beta, gamma using equation 9, 10, 11. Where alpha plus beta plus gamma value should be equals to 1, and the value of alpha, beta, gamma should lies between 0 and 1. And here lambda represents the decision maker preference, which value also lies in between 0 and 1. Here three cases arises. When lambda equals to 0.5, it is neutral case. When lambda is less than 0.5, it is risk averse case. And when lambda is greater than 0.5, it is risk seeking case. Then deposited value is calculated using equation 12. Then rank the alternatives based on the deposited values. To establish the relevance and effectiveness of our proposed flexible deposition process, a case study on makeshift hospital site selection is represented. Here, a decision-making committee needs to select most suitable location for establishing a makeshift hospital from 4 alternatives: urban community center, sports complex, school campus, and fourth one is open ground area, which is based on the following criteria: accessibility, infrastructure availability, cost, environmental suitability. The decision makers express their evaluation using linguistic terms, which are represented in table 1. In the left side column, linguistic terms are present, and in right hand side column, trapezoidal interval type 2 fuzzy set representation terms are given. Then the decision matrix based on experts' opinion given in table 2. Then they differentiate the decision matrix calculated in table 3. Here, one simple examples for A1 under C1 is calculated here. Similarly, other values for table 3 is calculated. Then ranking of the alternatives is represented in table 4. And the final ranking is A4 is greater than A2, is greater than A1, is greater than A3. And the final result shows that A4 is the most suitable location due to high environmental compatibility and adaptive infrastructure. The results and comparative analysis. To validate the effectiveness of the proposed adaptive deposition method, the results obtained are compared with a commonly used deposition technique, namely average expectation method, which deposited decision matrix is represented in table 5, and its normalized value is calculated using equation 14, and its score is calculated using equation 15. And we conclude that the ranking in AE method and our proposed method is almost same. Here is the comparative analysis of alternatives in different techniques. If you talk about ranking consistency, then both methods produce the same ranking order, and this is the reliability of our proposed method. If we talk about discrimination power, then discrimination power is calculated by a maximum score minus minimum score. In AE method, discrimination power is 0.22, and our proposed method, it's 0.88. So the proposed method shows higher discrimination, meaning better separation of alternatives. In conclusion, in order to improve the decision-making accuracy in uncertainty, this study introduced a unique adaptive deposition technique for trapezoidal interval type 2 fuzzy set. The proposed framework produces more flexible and realistic choices in contrast to traditional approaches. A case study of hospital site selection in crucial situation is used to illustrate the efficiency of the suggested approach. Overall, by skillfully fusing simplicity, flexibility, and accuracy, this suggested adaptive deposition method provides a substantial improvement in fuzzy decision making. Our proposed method can be validated by taking a large amount of data set to manage the uncertainty. This technique can be integrated with other methods to get more better results and can be helpful in different case studies. These are the references. Thank you. Hello.
Thank you for your presentation.
Hello?
Dr. You're audible. Thank you for your presentation. Dr. Mahesh, do you have any questions?
No.
Thank you for your presentation, Bandana.
Thank you.
Now we have Gautami Lee presenting the paper titled Neuromorphic Neural Networks on FPGA for Parkinson's Disease Detection Using Vivado.
Hi Sanskriti, let me share the screen.
Hello, Gautami. You can share the screen now.
Hope my screen is visible.
Yes, it's visible.
Yeah. Good afternoon, all. So I'm Gautami V from Department of Electronics and Communication from Jesus Science and Technology University, Mysuru. Today I'm presenting a research work titled Neuromorphic Neural Networks in FPGA for Parkinson Disease Detection using Vivado. So this work has been carried out me along with my co-authors Sujata Kumari, Usha Rani, and Shalini MS. Now I would like to begin with a brief introduction of what is this Parkinson disease about. So this Parkinson disease is a neurodegenerative disorder that means the disease gradually damages the brain over time. So the main cause is a degeneration of the dopamine producing neurons located in the major part of the brain called substantial nigra. So currently we have no permanent cure for PD. However, early diagnosis can help doctors to treatment sooner, reducing the progression of symptoms and improve the patient's quality of life. Among the available imaging techniques, so MRI is a non-invasive and capable of identifying structural brain abnormalities before a severe clinical symptoms appear, making it suitable for automated diagnosis. So Parkinson's disease generally progresses through these three stages. One is the healthy stage where the brain functions normally and no PD related symptoms are present. In the second stage, which is considered as the earliest stage of Parkinson's disease, the third stage is a slightly neurological change begins inside the brain and the patient may not yet show obvious motor symptoms. So finally, the third stage, which is a Parkinson disease stage, significant degeneration of dopamine neurons will happen, and visible symptoms like rigidity and impaired movements will happen. So our work focus is majorly on accurately classifying the MRI images into healthy prodromal and Parkinson disease, enabling the early diagnosis. So, for this work, we selected MRI image because MRI, as we know, it's a non-invasive imaging modality that captures the detailed structures information of the brain. Unlike CT scans, MRI provides better contrast, subtle brain abnormalities associated with the Parkinson disease detection. It is highly suitable for automated image analysis for deep learning techniques. So PPMI, so Parkinson Progression Marker Initiative. It is a publicly available and clinically validated dataset widely used in Parkinson research. So this dataset contains the T1 weighted MRI images belonging to healthy prodromal and Parkinson disease subjects. So the slide shows how the dataset distribution is used in our work. So overall, the dataset contains 307 MRI subjects. Each subjects will have certain number of slices. There are 82 healthy, 118 prodromal, and 107 Parkinson disease subjects. The data sets were divided into training and testing sets. We evaluated the three different test train split ratios, that is 70/30, 75/25, and 80/20. During our experimentation, we observed that CNN model achieved the best performance using 70:30 split ratio, whereas SNN model achieved its best performance in 75:25 split ratio. So before developing a proposed model, we need to review certain number of research that is related to Parkinson's disease. So in the first work, they majorly focused on MRI matter biomarkers, but they did not have any FPGA implementation. In the second work, it was AI based MRI system, but it was majorly implemented on this in the software. In the third work, even though it was CNN based MRI classification, but hardware implementation was not yet touched. In the next work, they applied the deep learning into the midbrain MRI, but work majorly focuses on detection stage, like either PD or non-PD, like 0 and 1. They did not have the prodromal stage detection. The next work, the PD detection was majorly done on the FPGA, but in this case, they have used voice signals, not MRI. So in the next one, CNN on FPGA, as I said, they have used the audio signals, which is different from MRI based diagnosis. Overall, these studies demonstrate the effectiveness of deep learning on FPGA individually, but very limited work combines MRI, deep learning models such as CNN, SNN, and FPGA in a single framework. So the major gaps we identified was there were most of them were software implemented. So CNN models consumed higher computational resources and power, and FPGA implementation majorly focused on audio, voice, and ECG, but never on MRI. So these studies also performed binary classification with healthy and PD, but not prodromal. So therefore, we performed we instead of taking all these gap, we our work contribute to use a neuromorphic computing models like SNN, SNN on FPGA. So the major objective of the work was straightforward. First, we obtained the MRI images from the PPMI dataset. Second, we pre-processed the images using SPM25 toolbox in MATLAB and extracted the discriminative features using DTCWT and developed CNN SNN model capable of classifying the three stages of PD. Next, we implemented the train model on FPGA Xilinx AMD Vivado and compared both CNN and SNN model in terms of accuracy, FPGA resource utilization, and power consumption. So, coming to the major part, how we did this. So, the methodology. So, the slide illustrates the overall methodology of a proposed system. The workflow begins with the MRI images from PPMI. The MRI images are then pre-processed in SPM25 toolbox. During pre-processing, so we get the images as a raw form in the DICOM images, and we convert it into a NEFT format, followed by a spatial normalization and skull scripting and tissue segmentation to improve the image quality. Later, the pre-processed images are passed to DTCWT to extract the spatial and frequency domain features. The extracted features are then provided as an input to the CNN and SNN models for the classification into healthy prodromal and Parkinson's disease categories. After training, the both models are implemented in Vivado. Each of the layers are coded in Vivado. Finally, we evaluate the models using the metrics, hardware metrics such as LUT utilization, BRAM, DSP utilization, and power consumption. So before discussing the results, I would like to explain why we choose only these techniques. We choose DTCWT because it extracts the multispatial features and frequency domain features, preserving all the edge information and reducing noise, compared to the conventional DWT methods. So next we selected CNN because it for images it automatically learns the complex spatial and structural features for MRI images without requiring manual feature engineering. CNN have consistently demonstrated high classification accuracy in medical image analysis according to the literature survey. And we also why we selected SNN was because it mimics the behavior of biological neurons, like unlike its CNNs. So SNN process information only when the spike occurs. So resulting in an event-driven computation, this significantly reduces the switching activity, reduce the power consumption, making SNN highly suitable for FPGA implementation. So by combining DTCWT, CNN, and SNN, we aim to achieve both high classification accuracy and energy efficient and real-time hardware implementation. So these are the results. The slide presents how the implementation results looked for CNN model. The CNN model was trained and pre-processed MRI images and successfully classified. You can see in the image. So after training, the model was implemented on FPGA. All the layers were implemented straight from convolution, followed by the max pooling layer and global average pooling and the FC layers. So the hardware evaluation included resource utilization, LUTs, BRAMs, DSPs, as well as total power consumption. So overall, the CNN achieved good classification performance due to continuous computation, it consumes comparatively more hardware resources and power, as you can see. So coming to the SNN, the slide shows how the SNN was implemented. The SNN was successfully classified MRI images into all three stages. So unlike CNN, SNN information only done when the spikes are generated. Therefore, unnecessary computations are avoided. At this time, more significant was on switching activities resulting in low power consumption. The FPGA implementation demonstrated the SNN provides excellent energy efficiency while maintaining effective classification performance comparative to CNN. So next one we have CN, like the comparative performance between CNN and SNN implemented on FPGA. So CNN provides excellent spatial features and high classification capability. However, it performs continuous computation, so resulting in higher dynamic power consumption. On the other hand, SNN performs event driven computation. So, as a result, switching activity is significantly reduced. So, our FPGA implementation, we observe SNN consumes considerably very lower power while fewer hardware resources compared to the CNN. Therefore, all the both models have done effectively like done Parkinson detection. SNN is more suitable for real time and power in terms of power for medical applications on FPGA. So conclusion. So we successfully developed the MRI Parkinson disease detection using both CNN and SNN model. MRI images were pre-processed using SPM25 and using DTC-WT. All the discriminative features were extracted. Models were successfully implemented on FPGA Vivado, and comparative analysis demonstrated that CNN provides effective feature extraction, whereas SNN significantly reduces the power consumption through neuromorphic event-driven computations. So, therefore, SNN represents a promising solution for future low power and Parkinson detection diagnostic systems. So, and thank you for the attention. I hope my presentation was provided in a clear overview of a work. I would happy to answer if any questions.
I have just one question.
Yes, sir.
So whatever the cases that you have shown about data sets,
Yeah.
whether that much data set will be enough to decide the accuracy of the model.
Yes, so we almost have 307 data, like subjects data sets, which will each subject will contains around 7 slices. So on multiplying, we'll be having around 3,000 slices. So I think that will be enough for the since it's a novel work. I think for this work it would be enough, proving that
Good.
it could be implemented on FPGA.
Okay, fine. Good.
Thank you.
Thank you, Gautami, for that presentation.
Thank you, Sanskrit.
Now we have Dipti Manoj Singh presenting their paper titled Hallucination and Citation Reliability in Indian Legal LLMs, an empirical study with scaling insights.
Am I audible?
Yes, Dipti, you're audible.
Good afternoon. I'll present my screen now. Is my screen visible?
Yes, it's visible.
It is visible, right?
Yes.
So I'll start my presentation. Good afternoon. My name is Dipti, and today I'm going to present my paper on hallucination and citation reliability. Sorry.
Sorry to interrupt you. Can you please put this in slideshow mode or presentation mode?
Okay. Yeah. Is it fine?
Yes, thank you.
Okay. So today I'm going to present my paper named as Hallucination and Citation Reliability in Indian Legal LLMs, an empirical study with the scaling insight. The co-author is Dr. Anjali Nayak ma'am. So I'll start my presentation now. The current scenario, the current problem we are facing is that Indian courts, or as we know, we have levels of court, and we get n number of judgments. Like we have 15,000 plus judgment every year published on, like it can be paperwork or on the websites. So legal documents, they are also lengthy, complex, and citation heavy. It is not easy for a normal people to understand each and every line of the judgments. And the existing tools, they are only the present existing tool, they are on keyword based searching. So it difficult for other lawyers as well for finding the relevant cases, and many more difficulties are faced by them. Normal people are also unable to understand the things the judgment sees. So general purpose of LLM, that mostly LLMs fabricates the citations and misattribute precedents and oversimplify the arguments. So the core question is that, like, are the systems reliable which currently we are using? So the related work or the related references I have taken were the current existing works were of Nyarag, and they mostly were based on, they never thought of summarizing the cases or anything, just they were based on keyword finding the cases on the basis of keywords. And there were also issues with hallucinations and citation reliability on the current existing works. So the most of the gaps we have found was the existing works were not fine tuned. Along with that, citation grounding were not efficient. Along with that, system hallucinations were important fact that were ignored. So the methodology in this paper, we have taken two LLM models on which we have performed fine tuning, and according to we have judged like how the models are performing after they are known with the facts and the cases. So the model versions were like we have taken Llama model with 1 billion parameter for the version 2, and the second version, it consists of 3 billion parameters. So fine tuning was for fine tuning we were using LoRa adapters for fine tuning, and along with that we have compared the results of our three models with the zero shot baseline models like Llama 3.1 8 billion along with Sol M 7 billion parameters, and these are the metrics we use for judging the model's answers. So this is the data set we have used for fine tuning. Actually, for the version 1, we have used the 15,000 data set, which was divided like a total data set we had of 77,500, which we have received from Kaggle and different free sources available on internet. So we have separately, for the first version, we have fine-tuned our model on the basis of, like, we have divided it into 13,700 for evaluation. And the data were of Supreme Court, the legal Q&A, Supreme Court judgments, and bail records. We have found it on Kaggle or on different sources. And in the second version, we have increased the data set to 20,000 K, and it was also divided into 19,000 and 1,000 for evaluation. Some more data also have been added in version 2, which have been found freely on the internet. So the development, the first version was of 1 billion, where we have done training for 2 epochs, and we have given it as a proof of concept. There were some of the things it proved correctly as compared to the other versions. Later, for the version 2, we have adopted 2 types of training purpose. Like for the first, we have used for 1 epoch, and the second we have used a stage training, in which we have used for divided the data set into stages, like into small amounts, so that training can be faster. Let's say further how it goes on. The 2 region, like the version 2, the stage curricula I have mentioned here. For the version 1 also, we have used the epoch, but in a single go we were training the data set, same as this version 2 standard part. So that's why it also perform in a way. But when I have tried to train version 2, the second model, 3 billion parameters, there was issue it doesn't show any changes. The result we got from version 2 standard and the stage 1, it was similar. So it concludes that even though we have complex the training for fine tuning the data set as well, it doesn't show any changes in that. These were the results we have gotten when we were using a version 2 for standard and the stage version. all the 5 models. Like when we have just trained version like 1 billion parameter and 3 billion parameter, we have fine tuned it, and later on we have generated results. Like for testing, we have used 603 queries to generate the result from these models, and same queries were used for testing the llama, the public models available. So after that, we have received this, we can say, these results after testing these models with the data set, with the same data set. So the final concluding, we got that hallucination is pervasive, and no model is reliable enough for solving the hallucination, because hallucination free response for all five models were like 0.7 to 12.6%, and even like our version 1 was like detecting correctly as compared to the metrics we have used for training or like for testing was the ROG-L, citation F1, and many more metrics. So accordingly, these conclusions have been made, and fine tuning can reduce the data but does not come too close to solving that thing. This is a proposed citation framework we have done. Like we have cited the cases for model output, and then verify the existing cases. Like if in the existing data set we are getting any citations or that, accordingly we have created the citations. And then the holding index judgments, like we have judgment summaries. So that also been included in that, and we were flagging it, like is it correct or not. It is like citations were like verified there. So we have also used human annotations here, like for 50 it total took 250 responses, 50 from each models. So accordingly, LLM was judged, human LLM has judged the queries the answers model have produced, and later on it was judged by human annotations, like are the judgment from the LLMs have been corrected or the queries are correct or not. So human annotations was also included in the study. Human annotation and judge LLM as a judge. These are the results we got after evaluating each and everything with the help of LLM as a judge, along with the human annotation in that. These are the rubrics,
Yes,
like which are things.
Sorry to interrupt you.
Yes.
This is just a gentle reminder that 2 minutes are left for your presentation.
Okay. So this is the evaluation rubric to understand how what all things have been solved by, like mainly the fine-tuning models. In that, V1 version was performing better in this form, and Sol M7B was also performing better as compared to this. So these are the results we have received from them. Limitations were that single human annotator was used in this, no multiple experts. So if we have used many human intervention in this, it can also help us to verify it more legally if the answers or the model is performing well or not. And only English and Supreme Court related judgments were used because they were available freely on the Kaggle. There are High Court judgments as well. Like in future, High Court level, district level also judgments can be used for this. And mostly Llama family models we have used, so we can try it with other models as well. These are the future directions. Like legal expert practitioners can evaluate this data very nicely as compared to the normal models or human who are using the evaluating the data. Hybrid, like we can add also RAG to decrease the hallucinations which have been faced only just by fine tuning the models we have. Fine tuning the already available models like Sol LM that we have used as a zero shot. It can also increase the model adaptability. Like also there is a low confidence output at the deployment because there is uncertainty with the answers, so that's why we won't be able to deploy it for the human use. And in future also we can use multilingual, like different languages like Hindi, Tamil, Telugu, Bengali, and other regional languages for generating the answers. Yeah, this is a conclusion we have made after performing the study, and these are the references we have used. From there we have tried to make a study more reliable. Thank you. Thank you so much. If any question, please.
No specific question. Thank you.
Thank you, sir.
Thank you for your presentation, Deepthi.
Thank you.
Now we have Quenzang presenting the paper titled Perception Reality Gaps in Human-Wildlife Conflict Mitigation, Farmers, Technology, and Governance in Rural Bhutan. Quenzang, you may start your presentation. Quenzang, your screen is visible, but you're not audible. Quenzang, please unmute yourself.
Hello.
Quenzang, you're audible, but your voice was echoing. Can you please restart your presentation? Please stop your screen share and share your screen again. Quenzang, while you're figuring this out, we will move forward with the next presentation and then you can come back and present again.
Hello.
Yes, Quenzang, you're audible.
Oh, I'm eligible. Okay. I couldn't unmute my. I'm so sorry. Okay. Hello. Can you? Am I audible now?
Yes, you're audible. Your screen is visible.
Okay. I'm so sorry. Apology. I couldn't unmute my because maybe of some technical problem. Hello. Good afternoon. I'm Kinzang, and currently I'm undergoing my PhD at Edith County University in Western Australia. So today I will be presenting on the perception reality gaps in human-wildlife conflict, a small study carried out from the central Bhutan in one of the remote rural Bhutan. For my today's meeting, I have been joined by my supervisors, David Cook and Lisa Armstrong. So to begin my presentation, so I will shortly cover on the background and the research gap, the study aims and questions, methodology, the key findings from my focus group discussions, then on the discussion, then on the policy implications, research limitations and future research, and conclusion and contribution to the existing literature. So on the context and the background and the research gap, the human-wildlife conflict is a chronic socio-ecological challenge and not an isolated incident, which threatens the rural livelihoods, governance systems, and the food security across especially the developing world. In Bhutan also, like rising human-wildlife conflict is linked to declining food self-sufficiency and also on the psychological distress for the farmers, and also because of the persistent human-wildlife conflict, also leading to the abandonment of the farmland, especially the rice fields. According to the literature, it also states that the technology efficiency or the technology deployment in the rural areas largely depends on the regular or proper maintenance, depending on the landscapes, the institutional or governance capacity, and not the technology or the physical technology deployment itself. The existing literature gap, the existing literature focuses mainly on the device performance, like technology, for instance. The technology that I interviewed on the multiple of farmers in the community is on the solar technology, like electrical, the electric fencing, and the basic the sound and light deterrent systems. So the existing literature talks mostly on the device performance and the species response to stimulus response to the as per the technology deployed in the field. And one of the key thing was like the damage, especially in Bhutan. There is limited empirical evidence especially on the damage counts of the crops, especially rice, and that has been viewed in isolation. And when there is, for instance, if there is increase or decrease in the rice production, from the governance or from the institutional perspective, they view this as a single factor, and they neglect the wider factors why there is increase or decrease in the rice production. So these are some of the research gaps that need to be viewed holistically. The wider gap was on the limited governance scholarship, and the existing literature focuses on the ecology and the conservation biology, which is dominant, and very little literature review talks on the governance side. So what has actually been overlooked was how farmers' expectation of the durable public goods diverge with a short-term institutional pilot logic. So when I say here pilot logic, basically means the technologies such as solar and electrical fencings, which the government instituted or deployed in the farming field, is basically of the short-term or the donor-funded short duration focused, and not focused on the long-term or the sustained manner. So these governance mismatches that the farmer's perception, on the other hand, thinking which is of the public durable good, which should be sustainable, whereas on the governance institutions focusing that as a pilot or the donor funded infrastructure. So these two inconsistent mismatches and is the main root cause of the technology mitigation failure. So my study will particularly aim and will answer the key questions on how do farmers' expectations diverge from institutional realities in human wildlife conflict, mitigation, and its consequences. So my study, the methodology that I used was basically on the qualitative case study methods, since I'm studying on the farmers and the local governments, the perceptions and expectations, and the institutions, and what institutions actually delivered on the technology deployment. So the study site that I choose consists of 6 villages in the remote central Bhutan, and the data collection, I have conducted the focus group discussions for the rice farming households. And also my focus group also consists of the relevant officials from the district agriculture, district forestry, and the local government officials. So on the analysis part, I used the inductive thematic analysis, thematic process, where I first familiarize myself with the transcripts of the focus group, where I did then open coding, followed by Excel coding, then on the theme development, reviewing, and review and naming. And I used the NVivo 15 software to analyze the data, and in addition to the manual review, in order to strengthen the rigorousness or the quality or in-depthness of the research process, triangulation across farmers and officials and official focus group discussions was made, and regular debriefing with the supervisors were conducted in order to reduce the biasness of the researcher. So on the findings, the first finding was on from the farmers' perspective. Human-wildlife conflict as chronic threat requiring sustainable solutions. So the farmers' expectations, or what farmers believed, expect, and understand about the technology deployment, that the farmers perceive that
sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Okay. So human-wildlife conflict. So the human-wildlife conflict, the farmers view that the technology deployed, that the solar and the electrical fencing deployed, is a public good, and it should be durable and should save the labor. It should be labor-saving public goods, and not the short-term pilot projects. And also that the labor and the technology deployment should reduce the labor and psychological burden of the farmers. And also that farmers perceive that when technology is deployed are not maintained regularly by the institutions, then farmers abandon them, and then they revert back to their old methods of guarding crops. So from the institution side, they perceive this as they deploy technology as a short-term pilot projects, or is fragmented. It's basically a pilot logic. For instance, solar and electrical fencing are deployed in these 6 villages, basically as a pilot or donor-based project for a certain number of years, without any proper monitoring. And there is a fragmented mandates among the various sectors like agriculture, forestry, and local governments. And there is no specific mandates there is unclear ownership of the maintenance and the cycling of the technologies deployed. And there is maintenance gaps on the technology employed. So then what really is the main findings? The farmers expect on the one hand, the long-term labor saving protection, the technology employed as a durable public infrastructure, while the institution delivered this as a short-term pilot interventions and time-bound. So there is a mismatch or the gap that has been created within the community on the technology, which resulted in the technology abandonment, erosion of trust, and then the farmers reverting back to the old methods of guarding the crops, nightly guarding the crops. So therefore, through my research, I can say that the failure of the solar and the electrical technology deployment is socio-technical and not technology. Not the technology, not the physical technology itself is the failure, but it's of the social factor. The social factor, that is the what institutions really delivered in terms of technology deployment, in terms of that there is lack of maintenance, lack of budget. For instance, the farmer cited the lack of the inadequacy of the solar inverter when it is being shared within the household. The inverter's capacity is low to be effective in order to control the wildlife intrusion into the field. Similarly, there is lack of the durable solar electric poles. So these are some of the social factors besides the actual technology. So on the other hand, the farmers view this as a technology without government support fails, even if the technology is promising. So therefore, this gap has lead to the unsustained the deployment of the solar and electrical technology in the farming communities. So therefore, these are the 5 governance embedded recommendations that
Excuse me,
are
Quincy.
important to.
Excuse me, Quincy. Sorry to interrupt you. The 10 minutes allotted for the presentation are over, so
Okay.
please conclude.
Okay. So if I have any question, I can.
I must appreciate the work that you have presented. It's really good that you are actually working on, the real model. I have only one question. How, the economical feasibility will be, workable for this?
Sorry, can you repeat the question?
How economical feasibility will be workable?
Oh, yes.
Budget.
Sorry?
Yeah, just I'm
Hello?
asking about economical feasibility. Am
Yes.
I audible?
Yes.
Yeah, continue.
When I conducted the focus group, the farming communities well appreciated the government's initiatives on deploying like solar and the electrical and color fencing in the communities, which is very very viable. Even the solar and the electrical fencing and the color fencings are being provided on a cost sharing mechanism sort of thing, and even the farmers well appreciated, and they are keen to take up any sort of technology that have the viability to deter animal from incursion into their field. So I think that such deployment of the technology would be economical because the cost burden has been the 100% cost burden has not been levied on the farmers. It has been equally, a certain portion has been borne by the government. But the only issue here is that when the technology stops in like deployment after a certain number of years, then the burden, there is a fragmented or unclear accountability, and the responsibilities is not being clearly drawn, so which leads to the distortion or the non-usage of the technology. So from the economical point of view, I see that the technology deployment can really resolve the human wildlife incursion unless the government takes this as a regular activity rather than the project-based logic.
Okay, fine.
Thank you, Quincy, for the presentation.
Okay.
Now we we have Supriti Mishra, who will be presenting their paper titled Reforming Tradition Through Technology, Preservation and Transformation of Folk Music in Odisha. You may start your presentation. Supriti Mishra, are you present in this session? We'll be moving forward with the next presentation. Our next presenter is Susanna Isaac, who will be presenting their paper titled Philosophy-Guided Learning for Emotion-Aware Computer Vision, a hybrid, rule-based, and Bayesian approach to emotion regulation scoring.
Hello, everyone. I hope I'm audible. I can share my screen now.
Hello, Susanna. Yes, you're audible.
Okay, so good afternoon, everyone. I am Susanna. I'm a research engineer at INRIA. Today, I'll be presenting on the topic philosophy-guided learning for emotion-aware using computer vision. So the main problems that I'll be filling the gaps on, the problem statement that of this paper is that we face current emotional recognition systems, which are the static frame analysis. And these systems look at one frame and ask what the emotion is shown. But what I try to solve is that emotion regulation is not a single frame problem to solve. It's more of a process. So there'll be emotions that are being suppressed, that are masked, and a coherent form of expressions are shown, which can unfold over seconds. You cannot see someone suppressing fear by looking at a single frame. So that is. Hello? Oh, sorry. So the second one that I'll be solving here, the second gap that I'll be trying to solve is that there is no philosophical grounding. Existing systems classify emotions, but they never ask why that emotion arose, whether the body is consistent with what the face shows, or whether the expression has a coherent structure of a genuine emotional response. So the philosophers like Damasio, Merleau-Ponty, and Scherer gave us the theoretical tools to ask those questions. And I try to use them computationally to solve how emotion regulation works. And I have to say, there is no other prior system that has done it. And the third one is that there are no uncertainty estimates. So if I'm deploying a emotional coaching or mergers and acquisition intelligence, a number without a confidence level is dangerous. It could lead to many issues during a business deal. So these are the three gaps that I'll define during my presentation. The system addresses all three gaps through a 5-stage pipeline. It is being deployed in an asynchronous API. When a user uploads a video, it is queued via Celery and processed by a background worker. They get a session ID immediately and come back for the result when processing is complete. So using Celery and Redis, these are all the technological aspects that I'll be using for the deploying of the pipeline. Now, the main content is about the stage 2 to stage 5. Stage 2 extracts spatial features using a residual network of 50 and with 3 output heads. Stage 3 models the temporal dynamics using a bidirectional LSTM, long short-term memory with attention. Stage 4 is a core contribution, the hybrid philosophy module, which converts those features into 4 interpretable scrolls grounded in 4 philosophical frameworks. Then stage 5 is Bayes Philonet, which fuses those 4 scores into a final emotion regulation score, ERS score, with calibrated Bayesian uncertainty. Now, I can show you what stage 2, what I've got during my training results and how this has been structured and what is being used, and how the action units of 25 action units and the classes, like the 7 classes of emotion being categorized using the dataset EffectNet. So using EffectNet, which is about 500,000 annotated face images, the key architectural decision is a multi-head structure. Rather than just classifying emotion, the model simultaneously run these 3 output heads. The emotion head predicts one of 8 discrete emotion classes, sorry, not 7, 8, using softmax. The valence and arousal head produces continuous dimensional effect values, how positive or negative, and how activated the person is. The action unit head, AU head, detects 25 facial muscle activations using binary cross entropy. All 3 are trained together with a weighted combined loss. So emotion at 1.0, valence arousal at 0.5, action units at 0.2. Training using stratified splits, data augmentation, class balance, loss weighting, and checkpoint selection by macro F1 rather than accuracy to avoid overfitting on majority classes. The result is a best validation macro F1 of 0.666 above the reported EffectNet in the wild baseline of approximately 0.65. Overfitting was observed after epoch 15 out of the 23 epochs trained, and it stopped early, and is the primary bottleneck discussed in the limitations. It will be discussed in the limitation. Now, stage 3 is the temporal sequence modeling. So using the timestamps, we sequence the model and we use an input per frame with the emotion 8 classes, the valence, the arousal, and the probability gained from those 25 action units. So since the stage 3 is a temporal layer, and that is what fundamentally separates the system from frame level classifiers, the bidirectional LSTM takes sequence of per frame feature, vectors from stage 2, emotion probabilities, valence, arousal, and action unit activations over a 75 frame, 3-second sliding window. Bidirectional means 2 LSTMs run simultaneously. One processes the sequence forward from 1 to 75. The other processes it backward, frame 75 to 1. Their outputs are then concatenated. And then at any frame, the model has a full temporal context. So this would help them knowing what happens before and after. So this is a foolproof part of the stage 3. So after that, it goes to the attention layer, which then learns which frames matters most for the sequence level prediction. And then we are going beyond classification. So
Excuse me, Suzanne.
stage 3.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Oh, okay. Yeah. So these are the results you receive from stage 3 evaluation. And I have to mention that discussed the scored F1 of 0 due to only 2 samples from the data set. So it has been talked about by Lee and Deng, why they usually get misclassified with disgust due to the low data in the EffectNet data set. Now, the most important part. So this is where the novelty comes in. And stage 4 takes all the signals from stage 2 and 3, and it takes 4 deterministic mathematical functions, one per philosophical framework, producing 4 interpretable scores between 0 and 1. And higher always means more regulation load. So if you get a higher score, it will be very hard to, so it will talk about how much you need to regulate your emotion. So, and the lower means how much you don't have to regulate your emotion. That means you're perfectly fine in a situation, in a tense situation. So F1 implements Schroeder's component process model. It computes 5 appraisal checks: novelty, pleasantness, and goal relevance, coping potential, and norm compatibility, and combines them into a regulation effort score. So F2 will implement Damasio's somatic marker hypothesis. It compares the expected action unit pattern for the predicted emotion derived from Ekman's FACS prototypes against the observed AU pattern using cosine similarity. So it sees from the expected to the observed. So it finds how much similar in these two cases. Then, so what it means is that when the phase
Yes,
diverges
Susanna.
from what, right? Yeah.
Sorry to interrupt you. The 10 minutes allotted for your presentation are over, so please conclude.
Yeah, sure. And the stage 5, it goes through these are the results. This is where we use the Bayesian after we get these 4 scores. Yeah, and the ablation study is to show that if we don't use philosophy, how are the results being shown? And it shows that it's a vital part. So that means if you don't use philosophy, it goes -1. So philosophy frameworks are the most important part in this study. And the limitations is that, again, the small evaluation set that I've mentioned before, then the real video generalization, it overfits, and all of these have been mentioned before, and there's proxy ERS targets. So we use proxy values, not the external validity. Independent psychometric supervision is needed. So for coaching and data partnership is the next step. So this is just showing how emotion regulation score being used. Yes. So yeah, that's all I have for today, and I hope you guys like my presentation. Thank you so much.
Nice presentation. I have one question. The overall accuracy that you have shown 93.5%. Okay. But the F1 score for disgust is 0.0.
Yeah.
How do you plan to address this class imbalance?
So this is the imbalance that we face during the training. So the 0.0 is a very different part of the problem, which means that I need to have more disgust sample. So if I use more images per disgust, I guess the accuracy would have definitely increased, and the total accuracy of the reason why I said the total accuracy is 93.5 is that wait, I can show you. It's when I've implemented the project, it was able to recognize which is sad and which shows what emotion that needs to be regulated. And comparing with the truthy value and the expected values, we figured that this whole system is actually showing accurate regulation strategies. So in overall, this system works, but if I have more samples for the emotion class discussed, I guess that would answer your question. I would be having more accurate response to it.
Okay, great. Over to you, ma'am.
Thank you. Thank you very much.
Thank you for your presentation, Susanna. Next, we have Lopamudra Mohapatra presenting the paper titled Sustainable Education in the Digital Era, Navigating Systemic Barriers and ICT-Driven Interventions in India.
Thank you, ma'am. Good afternoon, everybody. Can I share my screen?
Good afternoon.
Is it visible, ma'am?
Your screen is visible.
Thank you. I'm Lopamudra Mohapatra from KIT University Research Scholar, along with my supervisor, Dr. Khushbu Kudus. It's going to start. My topic is sustainable education in the digital era, navigating systematic barriers and ICT-driven interventions in India. Let me begin from the research background. The first important point is technology widened learning gaps. During the COVID-19 pandemic, education shifted rapidly to online learning, but not all students had equal access to smartphones, laptop, access to internet, or digital skills. So many students, especially those from the rural areas and those who are economically challenged communities particularly were left behind. Hence, ICT maybe created a new knowledge learning opportunity, but it also has widened the gap, the educational inequalities. And if we talk about the second point, it's post-pandemic infrastructure view, but language teaching lacks. After the pandemic, as we say, schools and colleges improved their digital infrastructure, but language teaching has not progressed at the same pace. I mean, English language classrooms still rely on the traditional teaching methods, especially in rural areas. And the third point is about NEP 2020 sets a new direction that needs evaluation. NEP 2020 has set a new direction for education by promoting holistic, competency-based, and technology-integrated learning. But it is rather important to evaluate whether initiatives like Diksha, PME Vidya, state mobile apps are truly helping to reduce the educational gap inequality as well. Moving to the next slide. There are 4 objectives I have clearly studied from the paper, as it focus on 3 key areas. Like first one is the study investigate how the digital divide affects the use of technology in education across India, particularly in rural areas of India. And secondly, it examines the different dimensions of digital divide, including its access, uh, internet connectivity, digital literacy, and affordability. Finally, it explores how affordable ICT tools, AI-enabled resources, and recent Indian policy initiatives can help to reduce these gaps and make the education more inclusive and more effective. Coming to the next slide. Based on the objectives, the study addressed the following research questions. The first one is the question to examine how is the digital divide conceptualized in the context of education. Secondly, it focused on what forms of the digital divide take in Indian education, and thirdly, it explores in what way ICT can integrated learning, including mobile language learning, AI tools. This can help to bridge the gap. This study follows a narrative review approach combined with thematic analysis. The literature was analyzed based on the research questions to identify key themes and patterns. The review included scholarly articles, national reports, and international publications published between 2000 to 2025. And the data we have collected from major academic database such as Scopus, Web Science, Direct, Theory, Google Scholar, ResearchGate, and the literature search was guided by these keywords, as you can see. This methodology ensured a comprehensive and reliable understanding of the existing literature. This is the main point of the topic. If we discuss about the finding and discussion based on our reviewed literature, our findings show that digital divide is much more than lack of internet or devices. It is rather a multidimensional issue. It is a layered and dynamic process which includes its access, skills, and its effective use. That digital divide can be understood at three levels. Here we have reviewed as the micro, which focus on individuals, the meso level, which focus on schools and communities, and the macro, which focus on policy and investment by the government. At the individual level, factors like income, education, age, and gender influence technology matters. At the institutional level, it's merely more infrastructure and teacher play a major role in it. At the national level, government policies and investments shape digital inclusion. It also depends on some factors like motivation, physical access, digital skills, and meaningful use of technology, effective use of technology. Finally, in AI and ICT-based language education, unequal access and teacher preparedness create a major difference in learning outcomes. It is merely a gap, which also highlights a third level digital divide, which refers to differences in learners' participations and outcomes even when technology is still available. If we talk about the barriers to digital inclusion, the challenges that make it difficult for many students to benefit from digital education. Firstly, it's about unequal access. Many students still do not have access to smartphones, laptops, or reliable internet, which limits their direct participation in digital learning. Second, infrastructure gap. Many schools still lack good internet connection, electricity, and proper digital facility. It also makes it very difficult to use online learning and AI tools effectively. Thirdly, if we talk about teacher training, which is very, very important, teacher training plays a crucial role in digital learning and in the blending education as well. But many teachers have limited training in using digital tools and AI effectively, which reduce the impact of technology in the classroom. Thirdly, it's willingness and motivation. some of the teachers as well as students, and if we can say parents as well, as hesitant to adopt new technology due to lack of confidence, awareness, interest, and so on. Then last one is about socio-economic background. Students from economically disadvantaged families, if we talk about India also, cannot afford digital devices to internet access, which widens the educational inequality. And if we address these barriers effectively, we can make digital learning, digital inclusion more accessible, more inclusive, and effective for, we can reach to each and every students for this.
Excuse me, Lopamudra.
Yes, yes.
2 minutes are left for your presentation, so
Okay,
please
okay,
continue.
ma'am. Okay. As we can see, or the 20% of the population is at 7 years and above still illiterate with limits of their ability in digital education. 15% of the rural households have internet access as compared to 42% of urban households. 10% of the students in rural household can operate computer, whereas the figure is 32.4% in urban household. Then only 20% of the population has basic digital literacy, and even among 15 to 19 years old, only 40% possess their basic digital skills. And finally, there is a significant gender disparity with only 8.5% female rural population have internet access, digital skills. ICT tools and their implications in rural context. To address the challenges, Government of India has introduced several learning tools, digital education initiatives under the vision of NEP 2020 and the National Curriculum Framework to promote technology-enabled learning process. Like as we discussed, Diksha, PME Vidya, Swayam Prabha, Nishtha, which aims to reduce the digital access gap and support to remote blended learning, particularly for rural areas. We have different kind of cost-effective ICT tools, PowerPoint, online games, PJ, social media, e-learning platforms, AI-enhanced tools, which enabled personal learning, instant feedback, writing support. Overall, these techniques can strengthen rural education when supported by adequate infrastructure and teacher training. And we will talk about the challenges. Despite the growing adoption of ICT in education, several challenges continue to limit its effective implementation, as well as if we at the level of teacher level. Yes, yes.
The 10 minutes allotted for your presentation are over, so please conclude.
Okay, okay. We have challenges from both sides, from teachers as well as the students. There are some Government of India initiatives which have taken for the implementation and infusion of education, ICT education. It has smart classrooms, ICT laboratories, e-content repositories, e-books, educational televisions, and so on. And implications for policy and practices, it can be defined through structured policy intervention, teacher professional development, equity, gender and socio-economic accounts, and so on. Sustainable matters, as lastly, the central message, inclusion and sustainability matter more than technology alone, which continues monitoring the ongoing training and community participations. And from the conclusion part, we find that technology alone cannot bridge the digital divide. So India's post-COVID digital infrastructure has improved, but there is still a gap, a need for initiatives to strengthen ICT-based language teaching, which requires massive policies, trained teachers, equitable access, and strong institutional points. Together, these efforts can create more effective and inclusive learning opportunities. These are the references. Thank you so much.
No specific question from my end.
Thank you, sir.
Thank you, Narendra, for the presentation. Now we have Aman Kumar presenting the paper titled Taxonomy and Evaluation of Network Scanning Tools. Aman, you may start the presentation.
Hello,
Hello, Aman.
is my screen visible?
It was, but now the screen sharing is stopped. It's visible now.
Uh, Good afternoon, everyone. My name is Aman Kumar. I am going to present my paper that is Taxonomy and Evaluation of Network Scanning Tools. These are all the outlines we will cover in presentation. So, why service and version detection matters? So, if we do any vulnerability assessment of any company or system, we first gather as much information as we can, and also we need to identify what are all the softwares and version they are using. That's why uh, service identification and version detection matters. Like, we can find a open port, but that is only the beginning. To exploit any system, we want to know what are the exact version of which product they are using. So here is background, like what is port discovery and fingerprinting. So port scanning mechanism. There are mainly two type of port scanning. That first one is TCP SYN based, and second one is UDP scanning. Then what is service and version detection? Service detection is just identify the protocols like HTTP and SSS, etc. But version fingerprinting is actually finding what is the product and what is the exact version it is running. Then we have two types of scanning, that is active and passive. Active scanning is like sending some packets and analyzing each response, and passive is like we gather information without sending package. Then what is the problem statement I have identified? First is the gap is controlled comparison of scanning tools under adverse conditions. Uh, then second research questions. How do tools compare in port discovery, service ID, and version detection under controlled conditions? What trade-offs emerge between fast discovery and deeper fingerprinting? How resilient are tools to adversarial configurations? So I have identified 6-axis taxonomy that includes like techniques, detection target, scale, speed versus accuracy trade-off, active versus passive scanning, and analytical methods. So I have surveyed 11 tools for port scanning, banner grabbing, and passive fingerprinters. So I develop a Docker test bed to compare the tools. Then I have done comparative analysis of the results. So here is our result bed taxonomy. First is technique. It can be TCP, connect, async, synchronous, stateless banner, or passive or predictive. These are the tools like for TCP connect or SYN, Nmap Nmap can be used for asynchronous SYN-based scanning, Gmap and mass scan. For stateless banner, Gbanner, and for passive or predictive, POF and IP rates. Uh, for detection target, like can do port stack state, that is port is open or not, service or version identification, and OS fingerprinting. For OS fingerprinting, POF. For service and version, Nmap, Ggraph, and for port, Nabu and Gmap. Then we have scale, like the tool is suitable for host or subnet or suitable for whole internet wide scanning. For host or subnet, we have Rust scan, and for internet wide, we have Gmap. Then speed versus accuracy. Mass scan is preferred for speed scanning and Nmap for accurate results. Then active versus passive. Nmap is a active scanning tool, while POF and Jig are passive scanning. And analytical methods, we have rule-based, that is Nmap, and ML-assisted. We have some transformer models or detection models to scan only host that they that is probably active. Then tool survey. Here is a short table for all the tools. Nmap, mass scan, techniques which is used by the tool, and what it actually detect. Like Nmap to detect port status, service, version, OS, all. And scale is host or subnet wise, and speed is not for, it doesn't give good speed, but because it based on deep probings, and here it is reduced. Then how I have compared the tools. So uh, I compose a Docker which does 12 services that include multiple protocols and multiple versions, like Apache for HTTP, Nginx for HTTPS, OpenSS for SSS, VSTPD for FTP, Mailhog for SMTP, Bind 9.20 for DNS, MySQL, PostgreSQL, Redis, MongoDB, Telnet, and Memcached. And I have used these tools to scan them. The first is Nabu, Rust Scan, Nmap, Ggraph2, and Nuclei. So I have developed four scenario. First is S1, that is baseline. It has no restriction, all the 12 services on default ports. Then S2, I configure firewall. I have to drop SYN packets. Then S3 is scenario 3, that is non-standard port, like running HTTP on 8888 instead of 80, and MySQL on 13306, etc. Then
Excuse me,
S4
Aman.
spoof banner,
Sorry.
like
Excuse me,
uh,
Aman. Sorry
yes, ma'am.
for you. This is just a gentle reminder that 1 minute is left for your presentation.
Okay. Then S4 we have spoof banner, like then these are the results we got for port detection here. For port detection, Nmap perform 100%, and in these cases, then this is for service identification, and it is for version uh, exact version matching. So we can and here G is It's a pitfall for Ggrab, like it depends on standard port, so the results are not very good for Ggrab. Then here are the key findings that Nmap remains the most accurate standalone tool for all these. Then Rust scan achieved service accuracy by asynchronous discovery with Nmap fingerprinting, and discussion accuracy versus speed. Nmap is highest combined accuracy, but Rust scan gives fastest speed. Then resilience to evasion, like firewall filtering, it reduces detection rate, and non-standard ports. It doesn't give any challenge for full range scanner, but Ggraph broke here because of port assumptions and binary spoofing. Version confidence graded for our tools, and we cannot able to test mass scan because it uses its own TCP IP protocol for fast operations, while Docker uses shared TCP IP protocol of operating system. So we are not able to use mass scan on Docker. Then here are the open problems
Excuse me,
like
Adnan. The 10
uh,
minutes allotted to you for the presentation are over, so please conclude.
okay. So in here is the conclusion. Thank you. You can ask if any questions.
Yeah, nice presentation. Normally in real world environment, these tactics are normally combined. Did you have any taste on environment that normally blended both non-standard as well as the spoof banner simultaneously?
Sir, can you repeat?
See, normally in real world environment, these tactics are often combined. Have you
Yes, sir.
tested this in any of the environment where both blended non-standard ports as well as this spoof banner simultaneously?
No, sir. I just choose these 4 scenarios.
Fine.
But that will be good if it will be tested.
Yeah, that may help you a lot.
Yes, sir.
Fine. Thank you.
Thank you, sir.
Thank you, Aman, for your presentation.
Thank you.
At last, we have Neela Madheshwari presenting the paper titled Vehicle Rider Safety Enhancement System.
Good afternoon. Hope my screen is visible to all. I'm Neela Madheshwari from Mahindra Engineering College, Namakkal, India. My teammates are Lokeshwaran, Tirupati, Sanjay, Balaji. We are presenting today the topic Vehicle Rider Safety Enhancement System. These are all the contents we are going to discuss for this topic. Introduction. Our proposed system is a real-time Android-based application system that is enhancing the safety and coordination among group riders during travel using GPS, Firebase real-time database, and Google Maps API. Users can create a ride session and generate a unique ride ID which other riders can use to join, forming a connected group where each member's live location is tracked on Google Maps. The system includes advanced safety features such as distance-based alerts, join or leave notifications, voice alerts, and an emergency sound systems that shares live location with emergency contacts. Accident detection is implemented using accelerometer sensor data to automatically trigger source alerts during sudden falls or impacts. So, motivation behind this topic is group rides using motorcycles and vehicles are highly popular, and maintaining coordination, communication, and safety among the riders is a major challenge nowadays. We are having a lot of unwanted accidents in our roads already, we know. So traditional navigation systems like Google Maps focus only on individual navigation, and we cannot have the group-based tracking system or safety monitoring. So the proposed system address these issues by enabling users to create or join ride sessions, track all participants live on Google Maps using GPS and real-time database. The system ensures every rider's location is continuously updated and visible to all group members with intelligent safety features for emergency handling also. So coming for the literature review, GPS-based vehicle tracking system using Android. In this paper, the objective is GPS-based real-time vehicle tracking system using Android smartphones was implemented. So algorithms they used is GPS satellite-based positioning combined with the Google Maps in a way they have used. And live GPS coordinates are continuously sent to Firebase and visualized on Google Maps for all group riders. The same thing we are also implemented in our system. Accident detection system using accelerometer sensor. So in this paper, they have studied the effectiveness of mobile accelerator sensors for automatic detection of vehicle accidents. And the algorithm they used is threshold-based acceleration analysis, and they have used a sensor formula in order to identify the accident. So the relevance for our work is accident detection module is implemented to trigger automatic emergency alerts without user interaction. We are including that module in our proposed system. Cloud computing based real-time tracking systems. The objective behind this paper is real-time tracking systems with low latency, high scalability, and reliable synchronization across mobile devices. They use the algorithm based on cloud-based publish or subscribe architecture, and they used a real-time synchronization model that enables instant data reflection across all riders' devices. So that same synchronization is implemented in order to have the common view for all the riders is also implemented in our system. Real-time tracking and monitoring systems using IoT. The objective is to study IoT-based systems for continuous real-time monitoring of assets, people, and vehicles in connected environments using sensors and clouds. Algorithm they use is they have used MQTT protocol for lightweight message transfer, and cloud aggregation services processing they have integrated and storing and distributing real-time tracking data. The relevance is IoT inspired principles using mobile GPS sensors and Firebase as the cloud layer, enabling continuous multi-rider monitoring they have used, and we are using the same for our system also. So regarding the detailed proposed model, we are having various modules or phases in which the entire system is built up. These are all the 6 modules we are implementing as a whole model: user authentication, ride management, live tracking, safety alert, emergency source, and notification modules. So these are all the system requirements we have make use of for the implementation side. Regarding the modules, first one, user authentication module. So this one is responsible for user identity management and access control within the system. So the functions included over here are: first one is user registration, secure authentication using Firebase, and storing basic user details, preventing unauthorized access into the system. When a user opens the application, he or she must log in using the credentials, and after authentication, a unique user ID is generated, and the same ID is used throughout the system to track participation in rides. Next one is ride management module. This module is implemented for handling the creation and joining of group rides. The functionalities involved are creating a new ride session, generate unique ride ID for the user, allow users to join existing rides, maintaining a list of active riders. A user acting as a host creates a ride and the system generates a unique ride ID. Other users can join the ride by entering this ID. Once joined, all users become part of the same group session stored in the Firebase. Live tracking module. This is the main component of the proposed system and which is responsible for real-time location monitoring. The functions involved are continuous GPS location capturing, update location to Firebase in real time, display all riders in Google Maps, refresh location markers in real time. So each rider's device will continuously sense the latitude and longitude data to Firebase. The system listens for updates and reflects changes instantly on Google Maps and allowing users to see the live position of all group members. Next one is safety alert module. This module enhances rider safety by detecting abnormal situations and sending alerts. The functions included in this module are distance-based alerts between riders. Second one, join and leave notifications, voice-based safety alerts, warning when a rider is too far from the group. So we have to maintain the synchronization among all the riders. The system continuously calculates the distance between riders. If rider moves beyond a defined threshold, the system triggers an alert such as rider is 200 meter ahead likewise for the entire in order to have a group coordination. Next one is emergency source module. So this module is designed for critical situations where immediate help is needed. The functions included are we can send emergency alerts to saved contacts actually, and share live GPS location, activate manual source button, automatic emergency triggering. When a rider press the source button or critical condition is detected, the system sends the rider's current location along with the Google Maps link to emergency contacts for quick assistance. Next one is notification module. This one will handle all user alerts and updates.
Excuse
The
me,
function
Bharat.
will, yes.
Sorry to interrupt you. This is just a gentle reminder that 2 minutes are left for your presentation.
Okay, fine. Various functional results are users are able to log in and authenticate, ride creation and joining using ride ID. All riders displays on the Google Maps in real time. Location updates are synchronized. Join and leave ride events. Source emergency system successfully shared live location. Distance-based alerts are also triggered accurately. So this is the results which displays the safety status with the distance traveling in kilometer unit and riders last 20 rides information history also available in the system. So the comparative evaluation is done between the traditional navigation applications and our proposed system. Group tracking is available in the proposed, that is not available in the traditional navigation applications. Source emergency, we are having full-fledged functionality, whereas we will be having limited and manual options. Distance alerts is available in the proposed, and real-time synchronization is available in the proposed system. So these are all the advantages we are having in our proposed system. So our conclusion, our vehicle ride safety enhancement system is developed as a real-time Android application, so that will improve safety and coordination among group riders by integrating GPS, Firebase real-time database, and Google Maps API. System ensures accurate and continuous location tracking of all riders with minimal latency. Safety features including distance-based alerts, join leave notifications, emergency response, and accident detection provides comprehensive rider safety coverage. System has been tested successfully for real-time performance, data synchronization accuracy, and emergency response, proving suitability for real-world group travel. The future scope, we can increase the scope of our system by integrating AI-based accident prediction, IoT smart helmet sensors we can implement using the system. Offline tracking mode is also we have to, and geofencing, voice assistant, and cloud-based analytics in these areas also we can use our system. So this is our conclusion part, and these are all our references. Thank you.
Hello.
Yes, sir.
Nice system that you have presented. Just
Thank
take
you.
an example. Suppose we have total 25 riders.
Yes.
What will be the budget requirement, okay, for implementation of the same?
Actually, we can implement this system in the mobile app itself, sir, since it is software. So most of the users or riders nowadays we are having Android-based mobile, so that is enough. So we can use the system in any mobile. So zero cost we can say.
Good.
Yes, sir.
From mine. Fine from mine.
Yes, sir. I am not getting clear.
Yeah. O from mine.
Pardon me, I am not getting clear.
Neela,
Sorry.
Dr. Mahesh is saying that he is done with all the questions. Thank you for your presentation.
Okay. Okay. Thank you. Thank you. Can I leave, right?
We are almost done with the session. Please stay connected until the end. Thank you.
Okay. Thank you.
Okay.
Attendance at the end environment.
Now we have Bhavya Bhola presenting their paper titled Predicting Honeybee Colony Health, a machine learning study with ablation analysis and future health forecasting.
Hello, am I audible?
Neela, please stop your presentation. Bhavya, you may start your presentation now.
See the screen? Hello? Hello?
Bhavya, you're not audible.
Hello? Hello?
Yes, Bhavya, we can hear you, but your voice is very feeble.
Just a second. Hello? Can you hear me now?
Dr. Mahesh,
Hello?
can you hear Bhavya clearly?
Hello?
Sorry?
Can
Hello?
you hear Bhavya clearly?
No, no.
Hello?
Bhavya, we can hear you, but your voice is very low. Could you try speaking a little louder?
Hello?
Yes, that's much better.
Hello? Yeah. So can you see my screen?
Yes, your screen is visible.
So hello everyone. My name is Bhavya Bhola from Thompson Rivers University in Canada. Today I will talk about our paper on predicting honeybee colony health using machine learning. So what is the paper about? We built a machine learning system that can predict whether a honeybee colony will be healthy at its next inspection using data from the current inspection and weather. We have two main contributions. First, we discovered a circularity problem in the dataset that was not addressed in any previous work. And second, we solved it by building a completely new experiment to predict future colony health. Let me walk you through it. So let me start with why this matters. Why do bees matter? Bees pollinate about 1/3 of the food we eat, fruits, vegetables, nuts. Without bees, food production collapses. So in the US alone, bees are worth $15 billion a year in pollination. But the problem is that beekeepers are losing more than 40% of their colonies every year for over a decade. So that is a huge problem. In our dataset, we have 2,404 real hive inspection records, which collected across 4 years. If we can predict which colonies are going to become unhealthy before the next inspection, beekeepers can step in early and save them. So the challenge here is beekeepers inspect hives every 1 or 2 weeks. By the time they see a sick colony, it may already be too late. So the question is, can we use data to predict which colonies will become unhealthy before the next inspection? So we used a real publicly available data set from Kaggle. The data comes from 188 hives across 13 apiaries in North Carolina and Utah, collected between 2016 and 2019. It is organized into six relational tables that we had to merge together. So what is the HCC inspection? Every week, a beekeeper checks six things about each hive. The first one is brood, which tells are the baby bees developing properly. Second is bees, is the adult bee population strong? Third is queens, which tells is the queen healthy and productive? Uh, Fourth is foods, are there enough food stores? Fifth is stressors, are there any varroa mites or diseases? And the last is space, does the hive have enough room? Um, so each one is rated as pass or fail in the form of zeros and ones. So this is the most important slide. The data set defines a colony as healthy only if all six inspection conditions are met, which are brood, bees, queen, food, stressors, and space must all be good. But here is the problem. Those all those six same attributes are also used as input features to train the model. So the model is not really learning anything. It is just figuring out the rule that was used to create the label. That is why we get 99.7% accuracy and AUC of 0.995, which seems amazing, but it's actually not a genuine prediction. So to prove this, we ran 5 ablation experiments, all using the same gradient boosting model. Experiment A uses only weather features and no inspection data and gets AUC of 0.778. Experiments B through E all include inspection attributes and get AUC around 0.995. The key finding here is that experiment B, which uses only inspection features and no weather features, give exactly the same results as experiment E, which uses everything. So this proves the inspection features are not alone driving the result, and smoot and high stress index add nothing in this setting. So the smoot here I'm referring to is the synthetic minority oversampling technique. The reason we need it is because only 36.3% of inspections are healthy and the rest are unhealthy. So this imbalance makes the model biased and they tend to predict unhealthy for everything. And high stress index here means the average of the 5 inspection attributes, which are queen, bees, brood, food, and space. A higher number will mean a more stressed colony. So how did we fix this? We completely reformulated the problem. Instead of predicting whether a colony is healthy right now using its current inspection data, which is circular, we predicted whether the colony will be healthy at the next inspection. The input is the current inspection plus current weather. The target is the future outcome, which is genuinely unknown at the prediction time. This is a real prediction problem, and we created 2,216 paired records by shifting each hive's health label forward by one inspection. Here are the results for the future health forecasting experiment. Uh, Gradient boosting is the best model with AUC of 0.8389 and accuracy of 77.9%. These are the honest numbers with no circularity. The LSTM model, which processes 3 consecutive inspections per hive as a sequence of time, achieves AUC of 0.9441. It captures how colony health changes over time, which other models cannot do. So the drop from 0.995 to 0.8389 is not a weakness. It is a correct result that reflects real predictive power. So when we look at which features matter most for future health, queen condition becomes first at 31%. This makes complete sense. Like if the queen is failing, the colony cannot replace its workers and will decline within a few inspection cycles. Apiary location is second at 22%, which reflects the very different climates between North Carolina and Utah. Stressors like varroa mites are third at 13%. If they are present now, they will likely be worse at the next visit. So days to next inspection is a new feature that we added here. The longer the gaps between unexpected inspections means more risk of undetected problems. So this slide summarizes everything I've said. We have 3 configurations. Full feature setup gives AUC 0.995, which is circular and not a real prediction. The weather only setup gives AUC 0.778 and is honest, but only limited to the current health. The future health forecasting gives AUC of 0.8389 with no circularity, and this will be our main contribution. It is the only one that gives beekeeper genuinely useful information that they did not already have after completing an inspection. So to wrap up, our ablation study showed that the near perfect accuracy in this data set is caused by a circular dependency between the features and the labels, and not by a genuine learning. We fix this by reformulating the task as a future health forecasting, achieving AUC of 0.8389 with a gradient boosting. Queen condition, apiary location, and stressors are the strongest predictors of the future health. And lastly, days to next inspection is a new engineered feature that we added. And like to sum up, we how frequently a beekeeper inspects their hives is itself a risk factor. Thank you.
Thank you for
These are the references.
Thank you for your presentation, Bhavya.
Thank you.
Dr. Mahesh, do you have any questions?
No, ma'am.
Okay.
Thank you, sir.
Thank you. And with that, we have come to the end of the technical session 11E. I sincerely thank all our authors for the excellent presentations and valuable research contributions. I'd also like to thank all the participants for being a part of this session of the 11th International Conference on Information and Communications Technology for Sustainable Development. That is ICT4SD 2026. I hope you found today's session informative and enriching. On behalf of the entire organizing committee, we extend a heartfelt gratitude for your continued support, not only for the 11th session of ICT4SD, but also for all the previous editions. We look forward to welcoming you again at the 12th ICT4SD conference in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference proceedings are expected to be published within 7 to 8 months. We kindly request your continued cooperation with the organizing team throughout the publication process. I would also like to express my sincere gratitude towards Dr. Mahesh for effectively chairing this session. As a token of our appreciation, we present this to you, sir.
Thank you so much, ma'am.
Before ending the session, sir, would you please like to share any closing remarks?
I must congratulate all the presenters for giving wonderful presentation. Simultaneously, I'm thankful to the organizer for giving me this opportunity to, work as a session chair. Thank you.
Thank you, sir. We really appreciate your presence. Now, before
Hi,
we...
Sanskriti.
Yes,
Hello.
Susanna?
Yeah, I just wanted to ask regarding the publication. So you've mentioned it will be 7 to 8. I didn't get the timeline again.
Okay, you'll receive your participation certificate within 2 working days, while the publication will take 7 to 8 months.
Okay. Thank you so much. Yeah. Thank you for the clarification.
Now, before we leave, I request everyone to please turn on their camera so that we can have a quick snapshot of this session. Thank you everyone for joining us today. I hope you have a great day.